Hi, so today I want to talk to you about onion services because they have some really interesting privacy and security properties, but at the cost of some usability issues. So onion services are a part of the Tor Network, which is a decentralized anonymity network, and it allows users to access the internet anonymously. And onion services are within this network here. They're only routable within the Tor network, and they provide server anonymity. And so this work here just looks at onion services and their associated usability issues. So we wanted to see how Tor users interact with onion services, meaning we wanted to see what users' mental models of onion services are, how they use and manage onion services, and then also some of the challenges that they are faced with when using onion services. And some of our main findings are shown here. Despite the extra security and privacy properties of onion services, we find that many users are confronted with usability issues like the ones listed here. They are confronted with issues discovering onion services, managing and remembering them, and then also with the susceptibility of onion services to phishing attacks. And so with this work, we hope to kind of shed light on some of these usability issues and hopefully learn from them to implement design improvements in the future. So for the rest of this talk, I want to go into more detail on onion services background, some of their security and privacy features. I'll then talk about the methods we use to run a user study and some of the data we gathered. I'll then go into detail on our results, specifically looking at issues with discovering onion services, some user thoughts on vanity onion domains, and how users verify onion sites. And then lastly, I'll touch on some future directions and conclusions from our study. So this here is an onion domain, and I want to point out a couple different parts that make it different from a normal domain. First, we have it ending in .onion. This is a special use domain, and it's reserved for use just in the Tor browser. Onion services are not resolved using DNS. They're actually resolved using distributed hash tables, so the whole process isn't kind of controlled by one central entity. This next part is a seemingly random series of characters here. It might be slightly difficult to remember, and it's the base 32 encoded hash over the server's public key. A little bit later, I'll talk about one way that people use to make onion domains slightly more memorable. And then this last part I want to point out, in this case, is an HTTP reroute, but onion services are not limited to HTTP or HTTPS, as they're built on top of TCP. And so this is some of the background on onion domains, but I also want to point out some security and privacy features. First of all, onion services are self-authenticating. So if someone gives Alice at the bottom here an onion domain, she can enter that into the Tor browser and establish a connection to this onion service. The onion service will respond with a public key, and Alice might ask this question of, how do we know this is the legitimate public key? Can I trust it? And because onion services are self-authenticating, she can take the hash of this key and compare it to the domain she entered in the Tor browser. If the two match up, then she knows she's speaking to the correct onion service. Onion services are also end-to-end encrypted. So once a connection is established to the onion service, Alice has end-to-end encryption. And then the last point I want to make here is that both the client and server are anonymous. Alice does not know the IP address of the onion server, and the onion server does not know the IP address of Alice. It looks like this here. Both Alice and the onion server establish Tor connections to a Tor relay. In this example here, I'm only showing 3 Tor relays, but in reality, there's more than that. And this Tor relay does not know Alice's IP address or the onion service's IP address. And so we can see that onion services provide some really nice anonymity benefits, but they're not perfect. And this is for a couple of reasons. One is they can still be susceptible to traffic analysis attacks. An attacker can use information like packet timing to infer things about either Alice or the content she's accessing. There's also a number of configuration errors that can be made when onion services are being set up, and this could potentially lead to a compromise or a susceptibility to attacks, whether it's security or privacy related. And then lastly, there's a series of usability issues that we think onion services suffer from, and that's where this work starts. We want to determine and identify what kind of usability issues there are. Next, I want to go into some details on our methods we used and the data we used to come to our results. So to answer the question of how Tor users interact with onion services, we designed a mixed method user study, and it involved data from interviews, surveys, and then we also gained access to DNS data from the B root server. So starting with the interviews, we conducted 17 interviews with people of diverse backgrounds. We asked them about both Tor and onion services, and these served as a more exploratory purpose to inform our surveys. And so we designed a survey that had 49 questions, a mix of open-ended and closed-ended questions, and we wanted to ask people about Tor and onion services again, more about how often they use it, what they use it for, kind of their patterns with it. And we got about 830 responses, but after filtering out for incomplete surveys, we had a resulting set of 517 responses. And then we supplemented both our interviews and surveys with data from a DNS root server. We had about 2 days worth of data. Recall that onion domains are not resolved via DNS, but if someone puts an onion domain into a normal browser, it will still make a record of this at the root server, but it will not return an onion service. And so we wanted to look at this data to get an idea of what onion services people might be trying to access. And after filtering out for all the correctly formatted onion domains, we saw that there were about 15,000 unique onion domains in this set. So using those methods and that data, we can start pulling out themes from our results. And so I specifically want to talk about onion service discovery, vanity domains, and how users verify onion services. So starting with onion discovery, an important aspect of onion services is that they're private by default, meaning it's the onion service operator's job to disseminate information about their onion service so that people can use it. And this makes discovering onion services a little bit more challenging, so we wanted to see how people handled this. And we found that the most common way from our survey respondents is using social networking. So for example, there are subreddit threads where people ask about different types of onion services. We also find that search engines are popular. There's aggregators that compile lists of onion domains and categorize them and potentially include some other information on them. And then lastly, random encounters seem to also be a popular way to discover onion sites on the web. And one example of this here is if we look at ProPublica's website. If you scroll to the bottom, you can see a button that says Browse via Tor, and this will direct a user to their onion service. Recall that I mentioned aggregators. This is an example of one here called Fresh Onions. And we can see a list of domains, some title, potentially, and then also some metadata like when it was added to this aggregator, if it's alive or not alive. A lot of the people we got survey responses from mentioned they had issues with identifying which onion domains are still alive or not. And we actually found it pretty surprising that a lot of our survey respondents didn't know aggregators or search engines like this actually existed for onions. A common theme is represented by this quote here that says, "I wasn't aware that onion site search engines exist. It's been near impossible for me to find them so far." And we think also part of the reason onion discovery is difficult is because of their naming. It's hard to remember and identify them. And one way people have tried to make onion domains more memorable is using vanity onion domains. So this is 4 examples here of well-known popular onion domains. We have ProPublica's, the New York Times, Facebook, and ProtonMail's onion sites. And to generate a vanity domain, someone just has to keep generating key pairs until the hash of the public key resembles the desired string. Now there's both good and bad parts of vanity domains. The good is that it could hint at the onion service's content. For example, if I see an onion domain that starts with NY Times, I suspect it might be the New York Times. On the other hand, this same thing can breed a false sense of security if we're only verifying the prefix of the onion domain. It leaves onion domains susceptible to phishing attacks. And then I also want to point out that vanity domains are economically unfair. It takes a lot of resources and power to generate this type of domain. And so entities or people that don't have these resources cannot generate vanity domains. And so we asked users in our survey their thoughts on vanity domains, and we found a couple of common themes. As one of our survey respondents said, and this echoes a bunch of others, they only memorize the first part of the domain, which is a big security issue specifically because of phishing. We also found that a lot of people had technical misunderstandings of vanity domains. So many survey respondents thought that vanity domains are a weakness in the hash algorithm used by Tor, which isn't true of vanity domains. There was actually a lot of outcry when Facebook published their onion domain because people thought this was a weakness if someone could generate a domain that looked like theirs. Many other survey respondents had thoughts along the lines of this quote: "These people who created their onion name using Scallion or other tools should notice that other people can make the same private key." Scallion is a tool that automates the generation of vanity domains, and this quote and this line of thinking also is not accurate. And so based on our survey responses, we came to the conclusion that phishing might be a real issue with these, both vanity domains, but also general onion domains. And so we wanted to use the DNS data from the B-root server to kind of look at what onion domains are in there and potentially identify either typos or phishing scenarios. So if we look at this example here, we have 2 onion domains, and these came from our data set. We can see that they're extremely similar. There's 1 character difference. And this could be an example of either a typo or a phishing site. And so the way to kind of identify this is by looking at the frequency of both of these in our DNS data set. And this is under the assumption that typos or phishing domains will appear much less frequently because they're up for a much shorter amount of time than a real non-phishing site. So we looked at our data set and we found that this top onion domain occurred 529 times, whereas the bottom one only occurred twice. And this suggested to us that this bottom domain could either be a phishing site or a typo, and we wanted to extend this analysis to the rest of our data set. So what we did was we first made a list of all the unique, correctly formatted onion domains, and then created pairs between all of these domains. to have all unique pairs of onion domains in our data set. And we wanted to assign a metric to it that said how similar it was. And so in this case, we used the Jarrow-Winkler Similarity Score. It's a string similarity metric that puts more weight on the prefix of the string. And the resulting score is a number between 0 and 1. And 0 means it's unsimilar, 1 means it's the same. And so we had a threshold of about 0.9, and we said anything over 0.9 was extremely similar, and those were onion domain pairs we wanted to look at a little bit more closely. And so from those results, we weighted these by frequency. We specifically wanted to see onion domain pairs that were extremely similar and where one of them was very frequently visited and the other was not. And so some of our results are shown here, where we see in the onion 1 column, this is one of the onions in the pair along with its frequency. Onion 2 is the other onion in the pair along with its frequency. And then the last column is the Jarrow-Winkler score. And so we manually investigated some of these onion domains. A lot of them turned out to be associated with known ransomware attacks, but a few of them were not. These 3 here are well-known onion domains for the Russian market, DuckDuckGo, and the Hidden Wiki. And we found that for each one, there were at least a couple of other onion domains that were extremely similar to it and much less frequently requested. And so based on these results, we believe phishing to be a real issue for onion services and wanted to see how users verify onion services as authentic. We asked this in our survey, and these are some of the responses. Most popular was copying and pasting, which doesn't really address the phishing problem, as an attacker can still advertise an onion domain as something else, and a user will simply copy and paste it. But what's more surprising about these results is that about a third of our participants said they either can't tell and or don't check the authenticity of an onion service. And so this is an area for improvement going forward in future designs. So to summarize our findings, we found that discovering onion services is challenging because they're private by default. Vanity domains are more memorable, but provide a false sense of security. And users are lacking a way to verify the authenticity of onion services. And so in this last part of the talk, I just want to touch on some future directions and conclusions. So based on these usability issues we identified, we can help make onion domains more usable. For example, we can make it easier for a website to announce its associated onion service. We can allow onion service operators to opt into publishing mechanisms. We can have Tor browser help with encrypted bookmarks and also create better documentation and education to better people's mental models of the technology they're using. And to conclude, despite extra security and privacy properties of onion services, many users are confronted with usability issues like susceptibility to phishing attacks, discovering onion services, and managing and remembering onion services. And we can learn from the issues these users have encountered to implement design improvements like better discovery mechanisms and better verification mechanisms. And so at this point, I'd be happy to take any questions. Yeah, so we advertised the survey to the Tor mailing list, also on social media and our research webpage. It's definitely biased towards Tor users. We wanted to interview people or have people respond that had used Tor and hopefully had used onion services so they could comment on it. We have more demographic information in the results in our paper, but it is skewed towards more kind of educated people that have used this type of technology.
So the problem that you bring up with phishing of the domains is very similar to the problem we get with the regular DNS service with internationalized domain names. And this Unicode character A looks a lot like this Unicode character A, but the binary string's totally different. I know you yourself are graduated and gone from Princeton now. Do you know if there's if the work is going to be continued to try and figure out ways to solve this problem, or are you aware of work being done elsewhere to do that?
I am not aware of that, but it's definitely one of the things that we've looked at for future work. I'm not aware of anyone currently working on it, but it's something that we should work on. Yeah.
Okay.
Hi, my name is Ram. I'm from Texas Instruments. The question I have is, when users are using Tor browser, one of the concerns they have, apart from all the advantages of anonymity and all, is that their node could be an exit node, and people think that some government service may be sniffing their node or maybe monitoring their nodes more actively than usual. So did you have any questions regarding that? Were people concerned about that when they're using Tor browsers?
So we did ask some general questions about Tor, not just onion services, and some people were worried. We kind of had a broad range of what people were worried about, and so there were definitely some that were worried about that scenario. Others weren't. Some were just worried about trackers on the web. It was like a very broad range of what people were worried about. We do have more of the information, though, on our webpage and in the paper on that.
Thank you.
The very short answer to the previous question is that onion services don't use exit relays, so they don't have the capability for the sniffing. So my question is, in the typo situation, it's somebody who they should have typed L, but they typed I, and it's not like there are two different sites that match to those private keys. But in the phishing scenario, there are actually two different private keys that somebody has brute forced. In the slide you gave us, it looked like there were a lot of typos. Did you visit them to see if there was a private key that went with them? Can you separate typos from phishing?
So this is something we thought a lot about because we couldn't differentiate the two. One is because a lot of onion services are short-lived. Even if we did try to visit it, it might not be up anymore, and it's hard for us to kind of say anything about that. We also were skeptical of visiting onion services just because of some of the content that we didn't feel we wanted to see. But there is definitely work in kind of differentiating between these scenarios.